All right, and thank you very much for coming to the second day of MidCamp. It's been a great event, and with no other ado, I am very proud to present our presenter for this time around, Tess Flynn, who will be presenting on a very important topic for us all.
All right, let's get started. So just in case you don't know what room you're in, this is Return of the Clustering Kubernetes for Drupal. So the first question you might be had is, where can I find the links that are in this presentation? Yes, this presentation is already online at github.io at socketwench.github.io/return-of-the-clustering. So go ahead and take a moment to write that all down, and then we'll get going. How do Jedi actually like do this? Like, this hood keeps falling down over my face. They must have like special Jedi hairpins or something. Okay. So you might be wondering, who is this weird person in front of you that's talking to you from your computer, and why are they dressed like a Jedi? And well, the answer to this is, I'm Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I'm a module maintainer, blogger, and educator, and a DevOps engineer at 10.7. Little moment about 10.7. 10.7 is a full-service Drupal web agency. We create and care for Drupal-powered websites. We are based out of Minneapolis, Minnesota, mostly. Actually, we have several employees outside of Minnesota right now, and we are a fully remote distributed company. And if you are interested, we have just released a podcast helping you to give you tips on how to convert your business to work from home. You can find that at 10.7.com. We provide a number of different services: site hosting and migration, Drupal 9 upgrades, site audits, and process consultancy. Give us a hi at the wonderful humans at 10.7.com. So, as you might guess from the name of this presentation, this is part of a trilogy. Yes, this is the third presentation in a series of presentations that I have been giving at various Drupal events for the last few years. The first one is Ride the Whale, Docker for Drupalists, which will tell you all about how to put Docker into your project workflow and how to actually standardize your environment throughout your team. Also, Avoid Deep Herding, Deployments Beyond Git, which will tell you how to create a new continuous integration distribution system for your sites and reduce any additional process overhead necessary to deploy new releases as you need. So a while ago, my boss came to me and asked, we already use Docker locally, but wouldn't it be great if we use Docker in production? And of course, you know, being a good DevOps person, I said, sure it would. And then a tumbleweed passed between us. But, well, let's talk about Docker in production. So earlier, before that conversation, I had been researching this. Docker in production can't be that hard, right? You take a Linux server, you put Docker on it, you put containers on the Docker, and that's it. You're Docker in production, right? So I did some research, and there was a number of valid criticisms. Some people called it insecure, some people had problems with its performance, and some people had less constructive criticism about it. And then I realized it was going to be a little bit more complicated in order to actually get this to work. So let's talk about the big one, Docker security. Docker maps the users between the host operating system and the container, which means that whatever user the containers are running is the same user that it's running on the host operating system. And this is fine, except most containers run as root. And this is really not good, because now, despite the fact that there's a number of different security sandboxing mechanisms within Docker to prevent access to the underlying host operating systems, there are a number of security bugs which allow container escapes. So this is actually a problem, and we need to work around that. So we don't want to use just any container we find. We want to security vet any containers that we use, and we want to make sure that they never run as root. Another problem is passing configuration. Usually we're used to using Docker Compose and doing that locally. And a lot of configuration is passed via environment variables. And this works locally because we really don't care too much about the security of our local development environment on our own laptops. We're mostly concerned about the security in a prod or a shared environment that has multiple people accessing it remotely. Environment variables are really not a great mechanism for that. And the reason why is because a lot of developers do not treat environment variables as securely as files. You can see this very easily by going to any hosted Drupal site and going to admin reports, status report, go to the PHP information, and on several major Drupal hosting platforms, you will find your database login right there. That's not good. So instead, we want to use a mechanism within Kubernetes called secrets and config maps. Actually, Docker also supports secrets, but we'll talk about that. Okay, so we're running the containers as non-root. We're not using environment variables to do any of our configuration. So now we can just put them all in a Docker host and wait a minute. What about multiple Docker hosts? So a single node Docker is really easy. All we have to do is install Docker on a single server, and we run all the containers on the same system, and everything works. The problem is that the scaling is vertical only. Your only choice when you need more resource is to make the server bigger, and that runs into a number of limitations very, very quickly. Some research has indicated that x86 architecture tops out around 16 cores of CPU. Any more than that, and performance goes down, not up. The other problem is orchestration. We need some component to actually coordinate multiple Docker hosts to act as one so that they can deploy instances, distribute load, and deliver resources. It's not every individual server within the cluster for itself. They all have to act as one. Now, Docker does provide an orchestrator out of the box called Swarm Mode. It's Docker's own orchestrator and is every installation of Docker, even on your own laptop. It's built in and it's free to use. So we'll use Docker Swarm. That doesn't seem so wrong, right? We'll do that. Fine. So how Docker Swarm works is that when you enable Swarm mode on a Docker host, it becomes what's called a node. And here's where all of us Drupalists have to sigh a little bit. Yes, another node. If we add another Docker host to the swarm, another node, that actually becomes our swarm. And we can continue to add as many nodes as we need to in order to fill out all of our capacity. The problem is this isn't really a complete solution. In order to make it work, we need a front-side load balancer that has the ability to know where the containers are within the swarm that need to receive the traffic. Once the load balancer receives traffic, it needs to route it to the particular ports within the swarm. Also, we need to figure out persistent storage. Swarm mode doesn't care about storage at all. So we have to set up a SAN, an NFS, some kind of external storage mechanism that multiple containers can access simultaneously. So really, swarm mode is only one piece of a cluster. It's not the whole cluster. Also, swarm mode had a number of different problems. It had a lack of hosting choice. There was Docker Cloud a few years ago, and it was way too expensive, and that's probably why it doesn't exist anymore. But the other choice is that we could self-host Docker Swarm, and then we could sort out the load balancer and storage. That's actually a perfectly valid option. The problem, though, for me personally, is that Docker Swarm just felt too uncontrolled. It made too many decisions for me and made me modify my application versus the infrastructure. The problem is that containers were the only manageable unit within swarm mode. Everything had to be a container, and every container also got its own internal load balancer. And this created a number of different Drupal problems because you can't have multiple instances of MySQL go through a load balancer because it gets really confused. The same with Solar, and in some cases Memcache as well. So after researching all of this, I just kind of felt like, that's it. I'm done. There's nothing more for me to do with containers. I might as well just go back to normal servers. That's all. But then, I found something. like a relic from a more fantastic age. And I knew that things were going to be different. So let's talk about Kubernetes. I mean Kubernetes. So Kubernetes is an open source container orchestrator. It was created by Google, but today it is maintained by the Cloud Native Compute Foundation. And the thing that I really like about Kubernetes is that it has expressive power. Pods are only one of many manageable objects within Kubernetes. This allows you to tailor Kubernetes to your application rather than the other way around. And this is vital for Drupal sites because Drupal, in a lot of times that we use it, functionally, it's a black box. We don't modify core deeply in order to run it on every individual piece of infrastructure. We want to install modules and treat those modules more or less as a managed unit outside of ourselves. So it's much more important for us to tailor the infrastructure to Drupal rather than the other way around. So how does Kubernetes work? In Kubernetes, we're going to have one or more servers that are worker nodes. These workers are going to run pods, which are our application. In order to make sure that all of these worker nodes work together, we also have a dedicated manager node. The manager node is going to monitor the health of the cluster and make sure that every node has an equal amount of work provisioned to it. We can add as many workers as we need to the cluster, and we can do this dynamically as we need to, and even take nodes away when demand lessens. And this is our Kubernetes cluster. We can connect the Kubernetes cluster directly to the internet. We don't need a front-side load balancer. Now, persistent storage is a bit complicated still for Kubernetes, but less so for a variety of reasons that we'll get into. The thing is that this is just how Kubernetes works physically. How does it work logically? So when we actually interact with Kubernetes, we're going to create a deployment object. That deployment object describes our application and the containers that it needs to run. In order for that deployment to be accessible from the internet or to access other services within the cluster, we define another object called a service. Then, if we need to access persistent volumes, we actually can create something called a volume claim that represents the persistent storage. So our deployment can actually specify how you can access me and what storage I need from inside Kubernetes itself. It doesn't need any external information for that. If we want to actually connect multiple applications together, we can actually have different applications reference the other deployment's service object, and that way they can communicate to each other. So this is a lot of ways to describe your workload, and really this is only part of the Kubernetes model. There's a lot more that I haven't really covered in here, and it's took me about a year to figure out just the pieces that we need in the Drupal world in order to make an effective architecture for Kubernetes. So let's go over these again. Deployments describe an application, not just what containers to use, but the amount of copies of that application that are running, called replicas, any health checks to make sure that we need to restart the application when necessary, and where in the cluster to place those applications. Services are a consistent application endpoint. They can be internal, external, or a load balanced application. Also, there are persistent volume claims called PVCs, not a pipe. These are a request for persistent storage, how much, from where, and how shareable it is. So that's a lot of objects that we're already talking about. How do we actually get these into the cluster? How do we deploy this? Actually, if you have worked with Drupal 8 configuration before, you already know how to do this. Everything in Kubernetes is defined as declarative YAML, and it is pushed to the manager node. This YAML can be patched, diffed, even replaced. It's very much like Git. It's really, really nice. When I saw this, I thought, I never imagined there was this much DevOps in the entire galaxy. Although Poe probably gave me some commentary about that for that cheesy reference. Next. So we have this wonderful infrastructure. Now, this is all shiny, but where do we actually use this? So let's get into our speeder and let's go to Kubi Station. So we can always self-host. Self-hosting is perfectly a good option for Kubernetes. And this might be the only option if you actually have an on-premises requirement or certainly legal obligations like HIPAA that requires your infrastructure to be in premises in a secure facility. So you can do this on internal and on existing hardware, or if you can use an external VPS service, you can take raw servers and create a Kubernetes cluster on a VPS service like DigitalOcean or Lineout. There's a lot less lock-in with Kubernetes because there's no really reliance on special APIs. Kubernetes is open source, and one Kubernetes is pretty much like every other Kubernetes. It's not really that different. The thing is, though, that if you're going to run Kubernetes yourself, you still have to worry about having staff to manage the cluster, to set up storage, to make sure that the cluster is working correctly, and that everything is secured. This is very important because Kubernetes does not install as a secure by default configuration. That's something that's very essential to know when you are running self-hosted Kubernetes. Storage is still tricky because you could set up a traditionally managed NFS. This becomes a single point of failure within your cluster, but it still can be effective. Other options might be Ceph, Rook, or Heketi, which have native Kubernetes integration and can scale a lot further and are much more fault tolerant. So those are different options that you can look into. So when I did this once, I actually decided to set up Kubernetes over a weekend myself on Lineout, and it was a lot of resource just to run one site. I was running 3 nodes at 6 gigabytes, and it was a lot of resource, and I'm a cheapskate. I just didn't want to do this, and I didn't want to pay for the extra manager node either. And I just thought, there's got to be an easier way. And fortunately for us, there is. Over the last 2 years, managed Kubernetes has exploded as a service field. It's like a virtual private server, but for Kubernetes workloads. So instead of buying a single server, you're now going to buy a cluster and configure that cluster to your needs. Typically, you only pay for the worker nodes instead of the manager node as well. Furthermore, the storage configuration is typically baked in, so you don't need to do it yourself. There's a number of different providers that you can find to do managed Kubernetes on your site. Amazon, Azure, DigitalOcean, Google GKE, and a whole bunch of others. There used to be a wonderful list of these around, and last night I found out that it no longer exists. So generally, I can just tell you, experiment. Go out and find each one, go and research each one, see which one of the pros and cons suits you best. Now for us at 10.7, and for me personally, we settled on DigitalOcean. And the reason why is DigitalOcean is a worldwide Kubernetes provider. It has a really straightforward REST-based API, but the most important part was the pricing was really, really obvious. They literally will tell you how much a month your cluster will cost upfront before you allocate it. You really can't get that from Amazon, Azure, or GKE. You basically have to wait for a bill for a lot of those. That might have changed, but that was the last time I looked at it. Yeah, you just have to wait for a bill. All right, so now we know where we're hosting this. Now we have to actually start interacting with our cluster. So let's figure out what our architecture is going to be to host our Drupal sites. Now, when I started out, I decided to use the smallest nodes available on DigitalOcean and create a 3-worker cluster of those nodes. And the reason why is because I wanted to start small and see if I needed to scale up later. Also, we're going to use 10.7's Flightdeck for the containers, mostly because we were already using them internally, we were very familiar with them, and if we needed to modify them at all to make it easier to work in Kubernetes, we totally could do that. It also helped that I wrote them, and I was making the cluster, so I'm cheating. So first of all, we start with a MySQL container, and we're going to back that by a persistent volume claim disk, and that's going to be our database server in our cluster. Then we're going to have 3 memcache instances that are going to cache any queries from MySQL. We have 1 memcache instance per worker node so that each one of those is going to be on their own independent hardware. So far, so good. All right. Then we're going to have 3 web engines. Web engine? What the heck is this? Well, This is something that's a bit different from Docker. In Docker, you only manage containers, but in Kubernetes, you manage pods. A pod can be one or more containers. So our web engines are actually two different containers in a single pod, one container for Varnish and one container for Apache mod PHP. We could also use Varnish. We could use three different containers in the same pod: Varnish, Nginx, and PHP FPM. There was no performance advantage with Kubernetes architecture with FPM versus mod PHP, and some arguments to Apache being slightly better in that case. Then we can connect all of this to the internet. All right, so let's look at some actual code. So here we have a deployment. That's going to describe our application. The first line is going to be the API version. Now, this API version is not the version of your application. It's not the version of this file. It's not the version of Kubernetes you're working with. It is the version of the API that this file is communicating to within Kubernetes. And there's actually a page buried in the documentation which could tell you which one you're supposed to use, but I have to look it up every time myself. For deployments, the standard one is apps/v1. Also, there's the kind, which is the kind of object that this is. This is a deployment, so we just have deployment. Next, we have the name of the deployment. In this case, it's under the metadata section. Name is web, so this deployment is called web. We have three different replicas, and we're going to also have a key value pair here that's going to be used by the service. Well, let's get to that later. Then we're going to have the image to use, which is 10.7/Flightdeck web. And then down at the bottom, we say open port 80 so that we can communicate to Apache, and port 6081 to communicate to Varnish. All right, so far, so good. Now let's talk about that service. API version 1, kind service, metadata equals web. Wait a minute. We have a deployment named web and a service named web. Doesn't that conflict? And the answer is no, it doesn't. And the reason why it doesn't is because these are different object types. So as long as there are different object types, the names don't conflict. I actually tend to name my services and my deployments the same name every time, just so that I know which one is associated with each other without having to open the definition. And how do we know how they're associated? It turns out it's this selector down here. So the selector app equals web corresponds to the selector that's up here, app equals web, in our deployment. And that's how the two are actually associated with each other. This service also is going to open port 80 and port 6081 and advertise that to the entire cluster. We're going to load balance that as well, so that anytime that traffic goes to our web engines, Kubernetes decides which one of those containers it's going to go to. So what else do we need to do? We need to figure out where to put the database login in all of this. Where do we put our configuration? So in Kubernetes, we can define something called a secret. It's defined as its own object, not as part of a container, and it is mounted into the deployment as a disk. So here's a secret: API version 1, kind equals secret, metadata name equals MySQL, and then afterwards we have a data section. Now, this data section is going to be defined as one or more items which are key value pairs. Now, I tend to like naming the item name after a file name because this is how it's actualized inside of the cluster. So we have DrupalDB name.txt, DrupalDB user.txt, DrupalDB pass.txt, and all of these must be base 64 encoded. Then we have our deployment. So let's go ahead and get the secret in use. So we have our deployment, our web deployment, and way at the bottom we have a new volumes statement which says we're going to use the secret MySQL, and we're going to mount that under the volume mount section, same volume name, at secrets/MySQL. So now this container will be able to find those files within secrets/MySQL/ whatever these file names are in order to get that particular information. Cool. All right. What else do we need to do? So it seems like we've got pretty much all of this licked right now. Now all we have to do is just make a shared disk for all of our web engine replicas so that they all have a place to put sites default files, right? It should be pretty easy, right? Right? It's not easy. This is where I really had a hard time, because one of the problems is that within persistent volume claims in Kubernetes on managed hosting, such as DigitalOcean, GKE, and others, you can only have a single writer. So you can't actually share it between multiple web pods. This becomes a huge problem. Now, you could orchestrate a way of directing traffic only to the first web pod, and that's the writer, and everyone else is just a copy that does only reading, but that gets complex really, really quickly. So what we decided to do at 10.7 instead is just not use any attached storage for the web engines. Instead, we decided to use fly system or S3FS, and then back that by an object store, such as AWS, DigitalOcean Spaces, Minio, or any other option that can work with S3. This way, we no longer need a file system. And the reason why this is actually important is because Drupal primarily manages static files. Now, this is static files from a cloud architecture perspective. We don't need block storage. And the reason why we don't need block storage for Drupal sites is because from a cloud architecture perspective, block storage is meant for high bandwidth, frequently changing, performant data. And after a bunch of research to uncover what all that gobbledygook is supposed to mean, I found out that a good example was the files which make up a MySQL database. So we're not storing that in sites default files. We don't need to worry about that. So we don't need block storage. We don't need attached storage for this. We can use S3 and it will work. And the nice thing is that object stores are multi-writer by default. We don't need to worry about multiple writers accessing the same endpoint because it is multi-writer out of the box. So what else do we need? Memcache and MySQL don't need any Kubernetes load balancing. In fact, we want to directly access these without any load balancing because load balancing can confuse these services. The only problem is that we do need predictable host names within Kubernetes. Now, Kubernetes does not like giving you predictable host names by default. That is intentional. The reason why is to prevent you from building hard requirements within your containers. So one way around this is to use something called a stateful set. A stateful set is a special kind of deployment. The host name is assigned deterministically rather than non-deterministically with a bunch of hexadecimal gobbledygook. This allows you to access it directly and predict which container you want to talk to. A stateful set kind of looks exactly like a deployment. The only difference really is that we're going to have a service name field that's going to match whatever the service is. After that, everything else works exactly the same. So this is a stateful set for our memcache. So API version app/v1, kind stateful set, name memcache, selectors are app equals memcache, 3 replicas, and then we have the memcache official container, the Alpine version, and then we expose the default memcache port of 11 to 11. Okay. We need to expose this stateful set with a service as well so that we can make it known to Kubernetes. So again, API version 1, kind service, metadata name equals memcache, and then the ports, and of course our selector. The important part is that with our stateful set, we want to turn off Kubernetes load balancing. And the way to do that is this weird line called cluster IP equals none. And what this does is it tells Kubernetes, yes, this service exists. Yes, please build DNS entries so that people can actually access it. But no, don't use load balancing when people are accessing it instead. Let people directly access the underlying containers instead. So we have one more spot left in our infrastructure. We need HTTPS. So the thing is that we don't want to run certificates all the way down our infrastructure into our web engine. It would be far better if we could terminate SSL at the very front of our infrastructure. And what we can do for that is called an Ingress. Now, an Ingress is a Kubernetes edge load balancer. It maps domain names to Kubernetes services, and it can terminate SSL. So here's what the Ingress definition looks like. API apps/v1, kind Ingress, metadata my cluster Ingress. We have a bunch of annotations here which allow us to configure the Ingress to fix rewrites, enable cores, set the file upload size, and then afterwards we have our host name. So anytime that someone requests example.com from our cluster, we're going to look for a service called web at this particular path and access it through 6081, which is our varnish port. And for TLS, we can actually have TLS hosts, example.com, and here's the secret that contains our certificate chain. What's that look like? So that Ingress TLS secret provides the combined certificate chain and the private key. So it looks like this, API version 1. It's actually a secret, a kind equals secret, and it has two different items, TLS.cert and TLS.key. Both are base 64 encoded. So that actually allows us to put a certificate within Kubernetes in order to actually SSL encrypt our traffic externally and terminate it internally from our cluster. But there's a problem. And the problem is, well, what about Let's Encrypt? We don't want to pay for certificates because that just seems like a racket. So how do we get Let's Encrypt in this? Typically, we're going to use CertBot in order to actually go and request a new certificate, and it does some configuration with Apache. But we're not doing that, and we're using an Ingress. How does this work? Well, actually, a lot of people had the same problem, and there's a product out there called Cert Manager. It is an open source certificate store and certificate provisioner for Let's Encrypt. You can find it at cert-manager.io. So we can see that in the Ingress, it's going to allow us to do name-based resolution, like example.com or example2.com can go to different places within our cluster, and that's fine. But how do we make sure that those different sites are separated from each other? How we do that in 10.7 is we actually assign each individual site its own namespace within the cluster, named after the site URL. This allows consistent deployment and service names across every individual site, which makes it easier for us to manage. All right, to me, all of this put together was really just DevOps happiness. It allowed me to do everything that I needed to do to run a site, and it was an effective infrastructure that was Kubernetes compliant without massive modifications to Drupal itself. Basically, I only needed to configure memcache, I only needed to set up fly system, and I was good. So now that we know what our cluster is going to look like, how do we actually get it into DigitalOcean? So let's get into our Xing. We're going to talk about the build chain of Yavin. So to deploy, we need to deploy all this YAML that we were just writing. Now, how we can do this manually is we use the Kubernetes command line application, kubectl, or kubectl, or kubectl, or do whatever makes you giggle, because there's 5 or 6 different pronunciations for it. Kubectl apply -f, and then the path to your YAML object. And you can repeat this for every YAML file that you want to deploy. Now, if you need to do this with namespaces, because you're using our model for multi-tenancy, you could use the -- namespace parameter on kubectl in order to apply it only to a particular namespace. The namespace has to exist first, and this link will tell you how to do that. So the problem is, though, we could combine all these files to make it easier, but we really need to remove humans from the process. Humans can be tired, they can be frazzled, they can be fried, they can make mistakes, they can make typos, and that can cause us to have a very bad day. We need to remove humans from this deployment process to make sure that we can do this much more consistently with a lot less effort on our part. So the thing is that almost every site that we work with is going to be kind of the same. We need a repeatable cluster. Clients tend to only differ in sizes, logins, and some features like memcache versus Redis. So In order to make this much more repeatable and reduce our work on ourselves, we're going to bring in another tool called Ansible. And this is where you can see that other talk called Avoid Deep Herding, which tells you all about Ansible. And we're going to use the K8s module within Ansible in order to deploy our YAML. How this works is that our DevOps person is going to define a bunch of group variables in Ansible, which describes the cluster. This goes into a Git repository. GitLab CI picks up that Git commit, reads the playbook that's inside of that repo, and then gives that over to Ansible. Ansible is then going to interact with the DigitalOcean API to provision the cluster hardware, and then kube control in order to actually send out all of our resources, all of our YAML. How do we authenticate this entire process? For DigitalOcean, we can create a personal access token and pass that to DigitalOcean's API as an HTTP header. What about creating the cluster itself? Well, a lot of this is going to actually be done with post requests with JSON, but it's a lot of work to figure that out, and fortunately, I've already done all the work for you. You can use the 10.7.DigitalOcean role on Ansible Galaxy in order to figure out how to provision your cluster. This handles scaling, node pools, and a whole bunch of more options. Here's an example playbook which actually provisions a cluster. So we have our Ansible playbook, DigitalOcean API token, DigitalOcean clusters, and here is what our cluster looks like. It's going to be called myK8s cluster in the SFO2 region. It has 2 node pools. One is going to have 1 vCPU 2 GB 3 servers, and then another server for 1 vCPU 2 GB, just 1 copy for the database, and that's it. That sets up the entire cluster for us, and we don't have to do anything else. And this can go right into our repos. So the problem, though, is we need to authorize kube control. And the thing is that when you create a cluster within DigitalOcean, you're going to get a kube config file. That kube config file only has a limited amount of lifespan. Those files are regularly re-rolled by DigitalOcean as a security procedure. So to make sure that we get a fresh kube control every time, we can use another Ansible role called 10.7.DigitalOcean_kubeconfig that interacts with the DigitalOcean API via our personal access token to get our authentication, our kube control, to talk to the cluster. Here's what a playbook that uses that looks like. And it's just DigitalOcean kubeconfig, the name of our cluster, and where to put the kubeconfig file. And then we call the role. That's it. That's the whole playbook. All right, what about the Kubernetes YAML itself? We actually have another role that we use to deploy all of our sites called 10.7.FlightDeck cluster. And it's going to create secrets, deployments, services, everything that you need to run a Flightdeck Drupal-flavored cluster in DigitalOcean. In fact, it should support virtually any kind of Kubernetes provider, even self-hosted. You can find plenty of examples on github.com on how to use this at github.com/10.7/ansible-role-flightdeck-cluster. All right. Finally, after all this time, we can stand over our enemy and go, "You failed, Lord Hostedness, for I am a DevOps, like my mentor before me." I should probably get the site on the cluster right now. Yeah, let's do that. We're all clear, Kate. Let's deploy this thing and go home. We're already home. Well, let's keep going. Usually we're used to updating a site in place. The server remains permanent and fixed, and we just swap out the site code when we do an update. This is usually used for shared hosting and some VPSs. Typically, we can deploy a site using SFTP, git deploy, and some CI systems do this. The problem is on Kubernetes, we have to deploy to each replica. And that's not simple. Sometimes we'll have 3 replicas, which means we have to do 3 different deploys. And those might be incongruent while we're deploying each one. And that can be a problem. We could use NFS to host code so that each one is updated simultaneously, but that just ruins our performance in other ways. So the thing is that this is just not how the K8s works. What do we do instead? Well, the more I thought about it, the more I realized that the site is the application. It should be the container. So what we should do is not use a container that just has Apache PHP on it, but it should have Apache PHP and all of our site code built into it. How does this work? So we have our developers. The developer is going to push the site code to a Git repo. GitLab CI is going to pick up those changes to our site, and inside of that repo is a Dockerfile. That Dockerfile is going to be used to build our Drupal 8 site. So it's going to run Composer, going to run npm run, npm, and anything else that it needs to in order to actually build the Drupal site code. Afterwards, we're going to take that and we're going to get an image from it, a Docker image. In order to make sure that that code is going to be preserved and accessible to Kubernetes, we upload it to a private container registry. That registry just hosts the container image. It's nothing particularly fancy. After that, kube-control can actually read from the registry to pull that custom image down, and then it gets deployed to the cluster. Where can I find an example Dockerfile which builds a Drupal site? You can actually find this at github.com/10.7/flight-deck-Drupal. This creates the necessary directories and also builds Drupal itself within the container. It also customizes the entry point so that every time the container starts up, it writes the settings.php file so that they all have access to the correct database. What about that private registry? Well, private registry just stores built site-specific images, and a Kubernetes needs an auth token that's passed in secrets in order to access it. Now, that's a lot to cover, and we don't really have enough time to do it, so there's a wonderful tutorial on docs.docker.com in order how to set up a container registry. Also, a number of different providers such as Quay.io, DigitalOcean itself has a container registry which is currently in beta, and a whole bunch of other providers which actually allow you to have private registries as a service rather than self-hosted. So when we actually have our container custom built, we need to modify our deployment. So now our deployment needs to actually have reference our custom registry. So my registry.tld, the registry's port, and then the container's name that has our site and whatever version it is. We actually don't use numeric versions for our containers. We actually use the GitHub short commit ID instead, because it's a lot more consistent in order for Kubernetes to understand which item to deploy. And the reason why is the tag names have to be different each time. Otherwise, Kubernetes will not redeploy it, even if the container image has been overwritten. So it's important to know that the tag names are very, very important. Also, we have the My Registry key, which is going to be a secret, which is going to have our authentication token for our private registry. So the last thing that we need to worry about is how do we control the update? When we deploy this out, we want to minimize downtime. So we have 3 replicas that have three different web containers, which are all going to get updated. If we do them all at once, we have downtime. That might not be so bad, but is there a way that Kubernetes can fix this for us too? And the answer is yes. There's something called a rolling update. It replaces running containers with the new image, and it does so sequentially. And this reduces outages. Flightdeck cluster does this out of the box and by default for any web container. So here's how it works. We're going to modify our deployment for our web deployment, and we're going to say that there's a new strategy type, rolling update, and in that rolling update, we're going to say allow one additional container in addition to the 3 ones that we already have. Make sure to only update 1 at a time, and then wait 5 minimum seconds after updating that container to make sure that before moving on to the next one to update. This way it reduces downtime. Every update's done sequentially. The best part about this is that the load balancing within Kubernetes is aware of the deployment process. So if anything goes wrong with the first container deploying, it gets stuck. But your site never goes down because traffic is now going to the other 2 containers. Now, that was a lot that we have to cover, and if you want to learn more, there's this wonderful book called KubernetesByExample.com that's free and online and tells you everything you need to know about a lot more about Kubernetes than I covered here. There's an interactive tutorial on Kubernetes.io, and also we have our own class called Hosting Drupal on Kubernetes on YouTube that also has all the lab material and slides online for you to use and learn how to interact with Kubernetes directly. I want to take a moment here to special thanks for having this event here to me, for having me here today at this event, even though I'm in my own house still, for 10-7 for sponsoring my time here, and my wonderful patrons on patreon.com/socketwench, which support my tutorial writing, my maker efforts, and also my fiction writing. Thank you. You can find this presentation at github.io.
All right. Thank you very much. I'm going to unmute everyone at once, and we can all give a big round of applause. All right, and back on mute, y'all go. So if you'd like to ask a question, please raise your hand, and I will unmute you, and we will unmute you, Tess. Yep, there you go. So please raise your hand and I will unmute you and we can have some conversation about this. And again, please feel free to use that chat function to type out your question. I thought I saw someone raise their hand. Maybe they're just raising the roof. Any questions out there? So if you're not familiar with Zoom, oh, there we go. Benji's got a question, so we're going to unmute you and lower your hand. You're on.
Hi, so sort of a silly question, but I noticed your slides are on github.io, and of course you're the DevOps expert. So I wonder whether you have a DevOps process for your slides.
So the slides are actually written in reveal.js. I try to use Git flow with them, but I kind of got lazy last night. And just push directly to master, but oh well. But it is managed in Git so that I can do that. Also, all of the slides are done with open source technologies only. So all the graphics are actually made in either GIMP or Inkscape, which is a lot of what the vector graphics are. And the source files, the source SVG files for those graphics are actually within the repo as well. So if you want to reuse them, go right ahead. They are, I think I put them under Creative Commons. So go ahead and reuse them if you need to.
So I do my slides using Markdown, and then I convert them to reveal.js with Pandoc, and it's all done with GitLab CI. But I am much lazier about my graphics than you are.
Yeah, I mean, I like doing the graphics. That's kind of half of the fun of doing these for me, I guess. Yeah, I don't really build any particular automation around the deployment. I just code it directly in HTML because there's really not that much additional work, and setting up the automation just didn't seem like it was necessary. Plus, it allows me to just run this locally if I need to without having to run a build process.
All right, thanks, Benji. We got a few more questions coming in over on the chat. So just curious why the choice of cache per node or pod and not a separate cache architecture, whether that is also hosted in Kubernetes or a global mass cache like Cloudflare, CloudFront, Acquia, etc.
Mostly because the problem is that we wanted to simplify the architecture and make it sure that if you want to add additional components outside of that, you certainly could. We do actually have a couple clients at 10.7 which do use Cloudflare and do use that front side cache, and then it gets moved over to Kubernetes. The idea behind this presentation was to present the simplest amount of architecture possible that allows you to build on top of it, rather than a very complicated architecture that has dictated components.
So thank you very much. That was from Adam Erwood. Howard, I skipped your question. You would ask first. I apologize. Could you talk a little bit? About performance compared with a single larger server?
So the biggest problem with this infrastructure that we're running into is the performance of the object store. Surprisingly, we found out that we could run 4 to 6 sites that have our traffic on it per cluster. and we have them running, I think, 2 vCPUs per node, 4 gigabytes of memory, and we're not anywhere near capacity on those systems. So we have plenty of CPU performance and memory performance. The biggest bottleneck is going to be the object store. You have to make sure that the object store has enough bandwidth and enough network location in order to access it quickly, because image regeneration is really going to kill your performance really quickly. So that is the biggest challenge. We are looking into maybe using MinIO for a lot of that, and then an external CDN instead of using some other solution like just a direct spaces access. And the reason why is because that will reduce network hops and probably make image derivative generation a lot faster.
Thank you. And reminder, feel free to use that raise your hand button if you want to get on the air and talk here. And got another question from Howard. How do rolling updates work with DB updates? Won't code be out of sync with the database?
It can be for a few seconds, but in Drupal 8, a lot of the traffic's going to be anonymous, and it's going to hit the caches first. So that's not going to typically be a big problem. So it doesn't completely solve the problem of outages, but it does reduce several major cases of outages that are due to deployments. And typically the deployments take about 4 to 5 minutes, even for a large site. So it's not that long of amount of time to be out if it has to be out.
Awesome. Here's another one from Pushpinder. Sorry if I've mispronounced your name there, sir, or ma'am. I'm not sure which. Do you see any issues with caching configuration import? Do you see any issues with caching / configuration import when you use this architecture in case if one pod goes down during deployment, another pod comes up?
So typically what happens is that when we do a deployment, if the first pod that's doing the deployment fails, it just gets stuck in a retry state, and it doesn't actually serve any traffic when it's in the deploying phase. So Kubernetes takes it out of the deck entirely and only relies on the running existing pods. This happens a lot of times with our deployments if we have some problem with Drush or some configuration doesn't work, or we just make a typo somewhere and something gets screwed up. And that stuck deployment is actually timed out after 5 minutes, and that's when it pings my phone to let me know that something went wrong. So it's actually worked out pretty well for us. Whenever we've had a deployment that didn't work out, the site never really goes down. It's only in rare cases where the site actually continues to keep working and then something later fails on it. We've also had problems sometimes where an individual pod will have a problem, and the best solution isn't to try to troubleshoot the pod, but rather just delete it and then have Kubernetes make a new one. And that typically also solves the problems too.
Right on. Thank you very much. Got to thank you as well on there from the asker. Any other questions out there in the world while we have Tess in the hot seat? Here we go. If this is from Adam Arrowwood, if the content of a node is changed, how do you handle cache flushing of that node? Do you just wait for the TTL to expire?
Typically, we actually set our TTLs fairly low. That is one of the limitations of this simpler architecture. We have been looking at ways of actually making the varnish into its own tier within Kubernetes itself, that we can actually use much more complicated tagging architecture to individually flush particular pages. We started looking into that. We haven't really deployed that yet. We're still in early stages. But for the last year, 2 years almost at this point, we have been running this with low TTLs, and it's been fine.
Awesome. All right. So I'll put one more time out there. If there are any other questions or comments, speak now, or you'll have to contact Tess offline, or I guess online somewhere. It looks like that's wrapping it up. So thank you very much again, Tess. I'm going to do that one more time. I know I caught everyone by surprise that last time. So everybody get ready. Let's give a big round of applause, or just tap your mic or what if you're in the office or whatnot. So unmute all. And thank you very much, Tess. I think that might have been.
Yeah.
I think that might have been louder if the Zoom didn't have the auto canceling function. Trying not to have everyone talk over each other. All right, so I'm going to unmute, and I'm going to turn the ability to unmute yourself back on for the time being, and stop the recording.